end-of-the-year math projects, both in 8th grade and in 6th grade, often involve students doing things which sometimes really don't look like math. For example, they sit back and propose something they want to do. They're going to connect the mathematics to it, but often it involves a lot of trial and error, experimentation, and doing things that are really outside their comfort zone. For example, we had one group decide to build a catapult. So they had to learn about the history of them, where they came from, how they worked, and began to study how catapults had changed over time. The idea of like a torsion catapult where you have to tighten this rope in a particular way. They suddenly realized the kind of rope they used, how tight they could make it, was related to friction, as well as a lot of the mathematics of how many times they could turn it, and then measuring the distances. And then they realized weight played a role too. Another group also working on a catapult really discovered and began to understand aerodynamics. When they were throwing different objects, they expected the objects that weighed the less to go the shortest distance. But in fact, it ended up being the objects with the least aerodynamics. Beanbags did much worse than small ping pong balls because a beanbag isn't shaped like a ball. And they made that connection. That connection was incredibly valuable because they began to see how different things interact in ways you don't understand. But they also learned more other lessons that aren't really mathematics. Like, for instance, if you use a power screwdriver incorrectly, you strip the screw, and then it's a waste of time. And learning to do things not once, but twice or 3 times. Some 6th graders decided they wanted to make an air cannon. Oh, they got all the parts, they read the directions, they put it all together, and it didn't work at all because they didn't seal properly. And so, oh no, and they had to go back and redo it correctly. And then after doing it correctly, they still had mistakes. Had to go back and look for others because tiny details make things really work. Real mathematics isn't 90%. Real mathematics is getting it right 40% of the time. I mean, you bat 400, you're in the Hall of Fame. And this is what one of the lessons the kids was learning was in the real world, there's lots of things that can go wrong, but the better you analyze, the better you plan, the better you think, the better it goes. And this is one of the big lessons I wanted the students to get out of this. And they did in many, many areas.